Hi, my name is Najeeb Siddique. I'm a product line manager for Nokia's Network Services Platform, or NSP. In this demo, we will do a brief walkthrough of how NSP's new workflow automation engine can be used to streamline organizational processes, simplify operations, and ultimately result in great efficiencies and service rollouts. Service operations today have become very complex. Rolling out new services involves coordination and planning activities across multiple user groups within the organization. Moreover, each step of the way, there could be errors and failures that results in even more time and overall cost of service deployment. NSP's workflow automation engine provides the ability to program tasks for each user group. In this example, we see that each user group can program their tasks and procedures into a set of actions. These actions will help satisfy the demands and criteria required to pass the service provisioning procedures through their organization. In this example here today, you can see that the planning and engineering activities are programmed into a set of tasks, in this case, commissioning of the device, the deployment of a service, and ensuring that the appropriate SLA requirements are met before the service can be activated. The activation procedures and requirements are managed by the network operations teams, and the network operations teams can also program the tasks and requirements to get the service to the next level, which is ultimately rolling it out for end customer use. In this mode of operation, the high-touch operational procedures required to roll out services reduced to a single user mode of operation. Here, a service operator can provision or can instantiate a service order without requiring intervention from planning, engineering, or network operations groups. And the only time that these groups would then get involved or need to be involved is to correct any failures or issues that occur in the network. I will do a brief walkthrough of the new workflow management tool that's available in NSP in 19.6. Here we have the Workflow Manager application. In this application, a user can monitor all the activities taking place within the workflow automation engine of NSP. You can see a set of KPIs of workflows and tasks that are currently under execution mode, that are waiting for input, that have failed, or that are paused. You can see a set of scheduled tasks, failed executions, as well as recently executed workflows or procedures within the NSP management system. For the purpose of this demo, we will walk through an example of end-to-end service provisioning. The Workflow Manager application allows you to define a workflow as a set of tasks and actions. In the workflow management editor, you can create a workflow. You can define the workflow requirements with tasks and actions that will be executed to successfully pass or fail this workflow. Here is an example of a full service automation procedure that has been programmed to commission a device, to deploy a service, check for SLA requirements, as well as activate the service if the previous tests and tasks are successful. Moreover, the workflow management application can translate the YAML definition of a workflow into a logical diagram. This diagram helps the user visualize the logical operations and conditions that are set for a workflow to be successful at each step of the way. Here you can see the green path of execution shows a successful scenario, and the red paths are the tasks and actions that are executed in case of failure in each layer of operations. We will do a demo of how this procedure can be instantiated and triggered, and we'll see how the service and the success and failure scenarios are handled within NSP. In this demo, we have created a very thin HTML client that is to mimic an OSS or BSS application that is integrated with the NSP Workflow Manager application. Here, a service operator can use a basic HTML page or simple APIs to trigger a service order. And in this situation, we will create a service order request by passing in a minimum set of inputs, mainly the endpoint A definition, the endpoint B definitions, as well as the minimum SLA requirements for this service. In this web portal, the user can select the operations that they want to perform. And they're presented with the list of inputs, the minimum inputs required to run this procedure. We will create a service between our site, between Vienna and Warsaw sites on ports 1110 and 117, and we'll set the minimum delay to 10,000 microseconds. When this workflow is triggered, navigating to our workflow manager application, we can see that a new execution instance is created for this workflow. At the same time, a user can monitor the real-time status of each task as it's executed by the workflow automation engine. Here, you can see that a port has been configured. The port A and port Bs were configured successfully. The workflow moved on to create a new E-line service. And as the E-line service is being configured, it's waiting for a response to confirm that the service is deployed. We will go to our service fulfillment applications to confirm the service definition and its deployment state. So service has been successfully deployed. And this task success can be seen within the workflow manager, where once the service is deployed, Ethernet CFM tests are executed on that service endpoint, on those service endpoints. The results for those Ethernet CFM tests are evaluated against the user-provided SLA requirements. And if those requirements are successfully met, then the service is activated and ready and available for end-user consumption. Similarly, we can extend the automation of a service provisioning process to also automatically correct any failures that occur during service deployment. In the next scenario, we will evaluate a situation where a service is successfully deployed, but the SLA requirements fail prior to activation. In this case, the workflow manager application can be programmed to perform other tasks, such as optimize the stateful PCE path and retry service deployment. It can create a new transport tunnel that meets the requirements for the service. It can possibly even optimize the optical service path in the optical layers to see if that will help us meet the IP path requirements for the service. In any case, if these corrective measures fail, then the workflow will automatically do a rollback to make sure that no remnants of a partially deployed or failed service remained within the network context. And once the rollback is complete, the workflow engine can send a notification to the appropriate user group. In this case, it will be the planning and engineering teams with all the required information that they need on the service model, the service definitions, the resources that were allocated for the service, the SLA requirements, the tests, and the test results. All the information they need to troubleshoot, debug, and troubleshoot the failures and to retry the service deployment in the situation. To do a walkthrough of the failure scenario, we will return to our portal, and we will create the same service. This time, to walk through our failure scenario, we will return to our portal, and we will create a new service order request, this time with a very stringent SLA requirement. What we should see is that the commissioning of the ports, the service deployment should be successful. However, during the SLA check task, the operations will fail. Corrective actions should be taken. But when the corrective actions fail, a full service rollback is triggered, and notifications can be sent to the appropriate user group. Returning to our workflow manager, we can look at the executions. Now we have created a new execution of the service order request. As we drill in, we can see the real-time status of the workflow and tasks that are being executed. In the service fulfillment application, we will see the instance of the service is deployed successfully. As the next step in the automated procedure, the workflow will now run the SLA checks, the Ethernet CFM delay between the two endpoints. When the delay tests are returned, we see that the service paths are not able to meet the constraints specified for this service requirement, and the service is a full service rollback is triggered, and the service instance is deleted from the network context. This execution path is shown in the workflow management flow diagram, where the real-time status updates of each of these steps is displayed. And as we can see that the real-time delay for this between the two endpoints failed, and a full rollback of the service was triggered. The service deletion occurred, and a failure message has been sent to the operations and engineering team. In the next scenario, we will see how a workflow can be augmented to integrate with closed-loop assurance capabilities within NSP. Here, a service is deployed successfully, and the SLA criteria have passed. Once the service is activated, the service provider may have a policy to monitor this service for 24 hours before it is made available to the end customer. During these 24 hours, there could be failures or traffic patterns that are unfavorable for this service released to the customer. These events will be realized in the Kafka notification bus in NSP. And once this workflow detects these events, corrective actions can be triggered within NSP to return the service to a healthy state. An example of these events could be to optimize the stateful PCE path. It could be to set service to maintenance mode and migrate all the LSPs or services using ports associated to the service. And if in those situations, if there's a failure, then the appropriate notification can be sent to the network operations team so that they can take action before the service is scheduled for release to the customer. I just showed you a working example of how NSP's workflow automation engine can help program tasks and streamline processes to turn a high-touch operation such as service fulfillment and service provisioning to a single user task where fewer user groups need to be involved except to take corrective actions or debug, troubleshoot advanced issues in the network. Thank you for your attention.